The nuclear physics, first 19 we already did. So this is question 20 about the nuclear physics and the mass defects. So in this question in 1960s to 1980s, the nuclear powered electronic uh, pacemaker were sometime used to regulate the heartbeat. Such pacemakers were used inside the body and were powered by a small radioactive source. One type of a pacemaker used an isotope of a plutonium, which is 238, as an energy source. The plutonium decay by alpha emission with a half-life of 88 years. Explain why alpha particles are not harmful to a person fitted with a pacemaker. Because first thing, alpha particles are like least penetration. They cannot even pass through the pacemaker, the walls of the pacemaker. That's why. So alpha particles are least penetrating, cannot pass through the walls of the pacemaker. Then complete equation for plutonium decay into thorium. Alpha emission is there, nucleon number 4. So nucleon number decreases by 4, so this will be 234. And proton number decreases by 2, so it will be 90. This is 2 here, sorry, I put 4. So proton number decreases by 2 and nucleon number decreases by 4. In the activity of the source in one pacemaker was fitted was 9.3 10 parts 10 becquerel. The energy released by each alpha particle is 5.5 mega electron volt. Calculate the power of the source 30 years after fitting. So first what we'll do, we'll find its activity after 30 years by using a formula A equals A naught e raised to power minus lambda t. And we can work out the lambda by, we have the half-life like 88 years, so we can find the value for a lambda. And then to get the power, so it is simply activity is how many particle emit in 1 second. So we multiply by energy of 1, like one alpha particle having an energy of 5.5. So energy of one alpha particle will convert into joules and then multiply by the new activity, will get the total power. So first we'll use the formula. The new activity, original activity, e raised to power minus lambda and t. We want power after 30 years, so t is there. But how to work out the lambda? Lambda is the decay constant, which is 0.693 over half-life. So it will be 0.693 over half-life, that is 88 years. Look, keep in mind, the unit of the lambda and the time should be inverse of each other. Like if time is in hour, if time is in hour, lambda should be in hour inverse. If time is in second, lambda should be in second inverse. So this will give us the value for lambda. So 0.693 over 88, this will be 7.8 into 10 to the power minus 3. And the unit will be time inverse, so it is year inverse. So A naught, original activity was 9.3 into 10 to the power 10. Lambda was 7.8 into 10 to the power minus 3. And that this time is 30. So we'll get this A, the new activity after 30 years, which is 7.34 into 10 to the power 10 becquerel. That is a new activity. And it, like, this is how many radiation it emit out every second. And energy of one alpha particle is 5.5 mega electron volt. We'll convert this mega electron volt into joule. So this will be 5.5 into 10 to the power 6 electron volt. To convert electron volt into joule, we multiply by 1.6 exponent minus 19. So this will give us 5.5 into 10 to the power 6 times 1.6 into 10 to the power minus 19. So it's basically 5.5 into 1.6. So 5.5 times 1.6 equals to 8.8. So 8.8, 10 power 6 and 10 power minus 19, it's equal to 10 power minus 13. So that is the energy in joules. So we have the energy in joule, and how to work out the power. Power is basically energy divided by time. So in case it will be activity multiplied by energy, because activity is how many particles disintegrate per second. So whenever we need the power of any radioactive sample, it's activity multiplied by energy of one particle. So the new activity was 7.34 into 10 to the power 10 times the energy 8.8 into 10 to the power minus 13. So when we multiply, this will give us the final power, which is about 0.06 watt. So this power is 0.0664 watts. Is it clear, this part? In part D, the modern pacemaker used lithium chemical batteries with a lifetime of about 5 years. So there's one advantage and one disadvantage of using a lithium battery pacemaker compared to one powered by plutonium. So first thing, what is the advantage? That there's no like it's not dangerous, so there is no danger of like the lithium ions. It's not radioactive, so it does not cause any ionizing or does not produce any ionizing radiation. Or even the batteries also, if we have to discard these batteries, so it is not easier to dispose of. But disadvantage is that like these batteries you can see only work for 5 years, but the plutonium work for 30 years. So the lifespan is short, so means must be replaced. The lithium batteries do not last for a very long time as compared to plutonium, so they must be replaced more often or require surgery every time. So advantage is that no harmful radiations, or you can say ionizing radiation. But the disadvantage is that we have to replace and carry out the surgery.